Today, we are going to crack the code. We're getting right inside an examiner's head to pull apart a real GCSE maths question. Why? So we can see exactly what it takes to nail those full marks, step by step.
You know that feeling, right? You see a question, you're pretty sure you know how to do it, but how do you show your work in just the right way to guarantee every single point? Well, that's what we're going to figure out today by looking directly at the official mark scheme.
Okay, so let's set the stage. Here is the exact question, straight out of a higher tier, non-calculator paper.
So, what have we got? We've got a solid triangular prism, and it's sitting on one of its rectangular faces. We're told the width of that face is 2 meters. The pressure on it is 80 newtons per square meter, and the total force is 720 newtons. Our mission is simple: find the length. And here's the best part. The exam paper gives you the formula you need.
All right, let's get into it. The absolute key to a multi-mark question like this is to break it down. We're not trying to solve it all in one go. Nope, we are going to build our answer 1 mark at a time.
So, the most important tool you have for this entire question is literally handed to you on the paper. Pressure equals force divided by area. See, the first hurdle isn't about memorizing something, it's just about knowing how to use what you're given.
Let's just organize our thoughts for a second. We know the pressure, we know the force, and we know the width of that base. The only thing missing from this whole puzzle is the length. That's our target.
So, where do we even begin? Well, if you look at the formula and what we know, the first logical step has to be finding the area of that base. And just doing that, just that one step, is what gets you your very first process mark. And check this out. This is taken straight from the official mark scheme. That P1 literally means process mark 1. The examiner is told point blank to give you a mark just for showing you intend to divide 720 by 80. You don't even have to get the answer right at this point to get this mark. How good is that?
Okay, so let's actually do it. First, we rearrange the formula to get area by itself. Then, we plug in our numbers. 720 divided by 80. A really easy way to do this without a calculator. Just think of it as 72 divided by 8, and that's 9. So the area is 9 square meters. Boom, first mark is in the bag.
Great, we've got the area, but we're not done, because the question asks for the length. So let's see how this first step builds towards our final answer. Let's go back to the mark scheme. The second process mark is for showing a complete process to find the length. And look, they give you options. You can take the area you just found, that's the 9, and divide it by the width. Or you could have set up one big calculation right from the start. Both ways are totally valid for that second mark.
So let's just follow that first method. We all know the area of a rectangle is length times width. We just worked out the area is 9, and the question told us the width is 2. So 9 equals length times 2. A simple little switcheroo gives us our final step. The length is just 9 divided by 2.
Okay, we are so close. We've shown the process for the area, and we've shown the process for the length. Now, all we need is the final correct answer to grab all 3 marks.
And there it is. 9 divided by 2 is 4.5. So the final answer is 4.5 meters. Getting this correct number after showing the right steps gets you the final A1 mark, A for accuracy. So here's the most important takeaway. A perfect, full mark answer tells a story. It's a clear, logical journey. You state the formula, you use it to find the area, and then you use that area to find the length. Laying it out clearly like this is exactly what the examiner wants to see. It proves you totally get the process. And that just leaves us with one final thought. This was never really about a triangular prism, was it? It was about a method. It's about looking for the formulas you're given and breaking the problem down into simple steps to get from what you know to what you need to find. So, how many other questions could you solve with that same simple blueprint?